All right, differential equations class. This last problem type that we're going to look at, the Laplace transform section, is something called the Heaviside function. And what this does is it allows us to take this piecewise function and make it into a single expression rather than multiple expressions. So I have this Heaviside calculator in Desmos that I made. And the way this works is there's the Heaviside function itself. I'm going to turn that off and just turn the Heaviside function on. And there's that turn on, it turns on at t equals 0 the way it's written now. But that's the definition of it. And then if we graph something or where we do something like 1, like that's a function, you can see we're always at 1 in this function, the height here, until we get to 2 pi, right, 6.28 roughly. And now this function 1 turns off, right, minus, so a minus sign turns off, and t minus 2 pi, that's like the shifting. If you recall, subtraction inside the parentheses shifts something to the right. So we're turning this thing off with subtraction of the Heaviside function. So it's like a switch. It's like a way for us to turn things on and off at different values for time. Now, what this is down here is just an example showing that I have the sine function, right? And I have this u t minus pi, sine t minus pi. So that's my sine function that's on, it's positive. And then minus the sine function at t minus pi at t minus 7 pi over 2. I'm turning this function, right over here that was on, I'm turning it off here, at this number, 7 minus pi over 2. So I'm going to turn that on so you can see it. And I will click these points so you can see there's 7 pi over 2. That sine function is being turned off. Right here at pi, it's turned on. So there's nothing at 0, 0, 0, 0, 0, and then when we get to pi, it turns on. And when we get to 7 pi over 2, it turns back off. So it's just the sine function for that tiny little blip between pi and 7 pi over 2. So positives on the Heaviside function, positives turn it on, negatives on the Heaviside function turn it off. Right, and then this is the function that I'm turning on and off. And notice it is the original where I turned it on, t minus pi, is what that needs to be where I want to turn it off at. All right, now so for this example, we've got 162 sine of 3t, and that's between 0 and 2 pi. So for 0 all the way up to 2 pi, it is that sine function. And then after 2 pi, it turns it off. There's what we're dealing with. There's the original function coming on, right? And then minus that function turning off. Okay, so I need that to turn it on at 0, right? And then I need this to turn it off, again, minus at 2 pi. All right, I'll need parentheses right there. So anyway, there is our a function. There's what it's telling us is happening. So this is what we need to make the g of t function here. So there is my second derivative plus 36 times the function itself equals, instead of writing it in piecewise format, I'm going to write it with the Heaviside operator. So ut 162 sine of 3t minus u t minus 2 pi times the function that I want to turn off there, which is 162. All right, and now what are we going to do? We're going to take the Laplace transform on the left. We're going to take the Laplace transform of all this stuff on the right. So there is the Laplace transform of our second derivative, and then it's just plus the Laplace transform of 36 times the function itself. Okay, so there's the left-hand side. Now the right-hand side, let's look at the Laplace transform table. All right, and then here is the one that we're after. The Laplace transform of the Heaviside function times a shifted function is equal to this over here. Okay, so we need that, but we also need the sine function. Okay, we need the Laplace transform of sine. That's what this means. The Laplace transform of whatever this function is that's being multiplied by the Heaviside function. All right, and by the way, the u with the little c underneath it, it's the same way as writing what our shift is. So u c would be the same as like t minus c. of the shifting of the Heaviside function. So that's the way we're writing it with Desmos, because we have to write it that way with Desmos for Desmos to understand what we mean by something like this. So that is another way to write u of 2 pi of t. That's the way it's written in the table. That's the way we would write it with Desmos. It's just, this is your shift, if you will. It's whatever that little subscript is, okay? But we can do it with subtraction with Desmos. All right, we also need the sign transform. So in that notation, we also need the transform of the function that's being multiplied by the Heaviside function. So that's the sign function. So we're going to need number 7 there as well. All right, so we got this constant. So I'm just going to put the constant 162 times. All right, and then the transform of the sine of 3t. Right, 3 is the value that's being multiplied by the t, so that's going to go up in the numerator. That's going to get multiplied by the 162. And then we have on the denominator s squared plus this number squared, right, which is, again, the number inside the sign. So that's 3 squared is 9. All right, so that is the Laplace transform of that piece. All right, and then we've got minus. Now we have, again, now it's shifted. So when it's shifted, that's when we're using 27. So we got an e to the negative cs, where c is the shift. Right, and it's minus c, it's minus c here as well. So it's a minus 2 pi. So it's a minus 2 pi s. E to the negative 2 pi s times the Laplace transform, again, of the sine, the same exact sine function that we just saw. So basically, this is going to look exactly like what we saw here, this 162, okay, because that's that part. The sine of 3t, that's this times 3 over s squared plus 9. Right, but we're going to have the shifting via the e to the negative 2 pi. Okay, so that is the Laplace transform of all this. And you can think of this original one, ut, that's t minus 0. So you know, that's technically shifted. It's just, you know, e to the 0s would be e to the 0, which is 1. So we wouldn't have to write it. Okay, so there's the Laplace transform, what we're starting with. And now it's just like we've been doing all of these Laplace transforms. There's going to be the grouping of the fs terms. So I have an s squared. And then the things that don't have the fs multiplied by that, I'm going to group those together. Now this is 6. This f naught is your initial condition. So it's I is our function here. So technically these should be i's. I naught, I prime naught. But f naught, that is 6, so that's going to be minus 6s. And then f prime naught is 36, so that's minus 36. All right, and then there just multiplied 162 times 3 is the 486s that you see. All right, I'm grouping together I'm just factoring out the fs in these two terms. These two, I'm going to move over to the other side, so it's a 6s plus 36 when it moves over to the other side of the equals and becomes positive. All right, and then finally dividing everything by s squared plus 36. All right, now I have f of s isolated. Now it's time to do partial fraction decomposition on these things. All right, so partial fractions, I'm just going to put pf partial fractions. So this is just going to stay the same. Actually, I'm going to leave it 6s plus 36. I'm going to break it apart in just a second. S squared plus 36. All right, now partial fractions. This becomes two different fractions. This 486, it's going to become a negative 18 over the s squared plus 36 part. Arrows are backwards. That's going there. And then this one is a positive 18 over s squared plus 9. All right, and then if you look really closely here, not too close, you don't have to look that close, it's pretty obvious, this is the exact same thing. It's just multiplied by e to the negative 2s and has a minus sign in front of it. So basically all I'm going to do is switch the signs here. So that minus will become a plus 18 over s squared plus 36. And that's going to get an e to the negative 2 pi. And then the same thing. This was a positive 18, but because of the negative, it's going to become a negative 18 e to the negative 2 pi s over s squared plus 9. All right, then last thing, I'm going to split this into two fractions. This is 6s over s squared plus 36. And then a plus 36 over s squared plus. All right, so that's split up into those two. And then we got a 36 over s squared plus 36 minus 18 over s squared plus 36. So these two are going to combine to a positive 18 over that s squared plus 36. So that's where all this is coming from. All right, and now it's time to start decomposing this. We've got it split up. The partial fractions are complete. We don't have any more separation we can do. We can't break it apart into any simpler fraction pieces or any fractions that give us these. So there's no more partial fractions we can do. So we're ready to start manipulating it. All right, this first one, we have an s up top and an s squared plus 36. So that looks like this cosine one. All right, s up top, s squared plus 36. So a is 6 here. So that is a cosine of 6s on top. So this is 6 cosine of 6t. So I'm going to switch back. This is, think of that, changing it to black font. That's like the inverse Laplace transform. So this is 6 cosine 6t. All right, now look at the sine one. It's a over s squared plus a squared. A is, again, it's 36, so a is 6. So we need a 6 up top. Well, we don't have a 6, we have an 18. So again, with a little manipulation here, this is 3 times 6, right? So I can say this is plus 3 times the sine of 6t, right? Because again, I need 6 and 6 squared. So there's that leftover 3 there. All right, now this is 3 squared is 9, so I need a 3 up here. So now I'm going to think of this as 6 times 3 again. It's just now this is the form of 6 times the sine of, instead of 6t, now it's 3t, because that is, again, 3 squared. The square root of that number being added to s squared is that coefficient on t inside of the sine function. All right, now we're back to the 36 here. So we're looking at this one. Again, think of this as 3 times 6, this 18 right here. So I'm going to think of that as 3 times, but now we have the e to the negative 2 pi s. This is going to be a shifted function. So this is going to be u t minus 2 pi. Right, and then what are we shifting? This is literally this same thing that we just did here. So it's this 3 sine 6t. So that's sine. All right, then we see the s squared, the 9, the 18. That's all this right here. So that's going to be a minus. All right, again, it's the same thing. There's an 18, so I'm thinking that is 6 times 3. So I had a 6 out front. This is minus 6 u t minus 2 pi. It's the sine of 3t again. So there is our overall solution. This is I. All right, now look at what's happening. We got 6 cosine 6t, 3 sine 6t, 6 sine 3t. Okay, what's happening here? It's turning on. So the sine 3 sine 6t is turned on at t equals 2 pi. We're turning off 6 sine 3t at t equals 2 pi. So this part right here is being turned off at t equals 2 pi. So that part's going away, right? And what's happening? We're turning this on. 3 more sines of 6t gets turned on at t equals 2 pi. So we're adding another 3 sine of 6t, which is a grand total of 6 sine 6t. So we have, 6, this just comes along for the ride, 6 cosine 6t plus 6 sine 6t. That's the solution from 2 pi to infinity. All right, but before we get to from 0 to 2 pi, it's all of this. All right, it's all of this from 0 to 2 pi. This one gets turned off, and we get 3 more of these, basically double the sine part of 6t. So anyway, I just wanted you to see the visual of that. I want you to see that it confirms with what technology will show you. All right, so here's the differential equation, the initial values. All right, and this is just the part from 0 to 2 pi. So there's the 162 sine of 3t. So I click equals, it runs it, there's our classification. But here's our solution. And notice it's 3 times 2 is 6, 3 sine 6t, 6 cosine 6t. Right, that's what we have right here. Right, from 0 to 2 pi. Again, at 2 pi, this gets turned on, this gets turned off. But initially, from 0 to 2 pi, it's just this part, all right, which agrees with what Wolfram Alpha says. But then once we move past that, this becomes 0, those same initial conditions. And if you scroll down, you can see there's our solution. It's just 6 sine 6t, 6 cosine 6t. And once again, that's exactly what's going to happen when we get to 2 pi, and this gets turned off. The 6 sine 3t, that gets turned off, and then we turn 3 more sines of 6t on, right? And you can see we do have that solution that Wolfram alpha is giving us from 2 pi on. Okay, that's the solution from 2 pi to infinity. So what does this do? It allows us to not do it in pieces, not split it up and say, okay, here's the solution before t equals 2 pi, and here's the solution after. It gives us a way to write both solutions at the same time.